But we see this, I mean, this has been well documented in the medical literature, and it's basically that small trials greatly overestimate the effects of treatments. And so this is a study where you compare the results. So the outcome measure is the ratio of the results, the risk ratio in the small trials versus the risk ratio in the big trials. And small trials, with less than 50 patients, compared to larger trials with more than 1,000 patients, they just get much bigger treatment effects. So small trials always greatly overestimate the treatment effects if you look across meta-analyses. So meta-analyses of small trials are really unreliable.
You mean a small trial or small and a published trial?
Yes, yeah, small and published trials. So these are all of the trials they could get hold of. Yeah, that's a very good point. The small trials that they could identify. Maybe if you could find all of the small trials, maybe there wouldn't be a selection bias. Maybe there wouldn't be such steep effects. But
what do you mean by small trial? Is there
well,
information about small
yeah, no, that's a good point. In this one, it was less than 50 patients. Really, it should be the size of a trial. Really, the most important thing is the number of outcome events. But it's kind of proportional to the number of patients usually, because the event rates are, within a range. So this is less than 50 patients compared to 1,000 patients.
So if I have hundreds, it can be called small or large?
You're absolutely right. Scientifically speaking, these terms have no meaning. Small and large. They only have meaning compared to each other. Yeah? So this is less than 50 compared to 1,000, yeah? And so trials with less than 50 patients compared to 1,000 have much bigger treatment effects. But I think that's a very good point, because small and large, in fact, I don't think 1,000 is necessarily very large. It depends. 1,000 could be small, it could be large, depending on the event rate. So why do meta-analyses of small trials often get the wrong answer? I think the most likely reason is selection bias and the inclusion of fraudulent randomized trials. So that I think that single-center trials that are done in a single hospital are more likely to be fraudulent than multi-center randomized trials. And I believe that because single-center trials are very private in a way. Everything's very private. You usually have one investigator and, in one hospital, and then they report what they've done, and you have to take their word that what they say they did, they actually did. Big trials are very public. So, like, the trials that I've talked about, like the CRASH-3 trial. I think we had something like 300 centers, 300 hospitals. So that's 300 centers doing the same thing. Everybody sees the protocol. If I wrote something in the manuscript that wasn't true, there'd be 300 people phoning me up and say, we didn't do that. We never did that. That wasn't the outcome. And so in big trials, the protocol is published, the statistical analysis plan is published, the data is published. So after we finish our trials, we put our data on a data sharing website. In fact, if you want the data, you can have the data, and you can check if the way we analyzed the results was as we said in the analysis plan. So it's all very public. There's lots of witnesses. But when you do small trials, it's very private and nobody knows. So I think selection bias and inclusion of fraudulent randomized trials. And so with selection bias, it's well known that so-called, we have to put this in inverted commas, statistically significant results, that means the p-value is less than 0.05, are more likely to be published, more likely to be published quickly, more likely to be published in English, more likely to be published more than once, and more likely to be cited. So, these trials where the p-value is less than 0.05, because these are the trials that people think are positive trials, right? So we talked last week earlier in the week about, there's no such thing as positive and negative, and this dichotomization is silly, but people believe it, and they're much more likely to. There was a very nice study about what German doctors do when they do a randomized trial. So a German doctor does a randomized trial. If the p-value is less than 0.05, they'll think, great, I can publish this in an English language journal because this is a significant result. And if the p-value is more than 0.05, they think, I'll have to publish this in the German journal, right? I don't know if it's the same in Japan. If you get a highly statistically significant result, if you think, great, New England Medical Journal, JAMA, and if you get a not significant result, it's the, Nihon Shinrigaku Journal. I don't know, I can't think of a journal in Japanese, but maybe that happens. And then, there's selective reporting of outcomes as well in systematic reviews. So these are good studies. So, cohort studies, 32% of outcomes in the publication were not in the protocol. 41% of outcomes in the protocol were not in the publication. So you can have selection bias at the level of the whole trial, and you can have selection bias at the level of outcomes within the trial. So if you collect 100 outcomes, in the protocol there's 100 outcomes. You collect 100 data on 100 outcomes from the patient, but the ones that appear in the paper are selected. So, and Professor Furukawa did a nice study, I thought, which was showing that the amount of Furukawa-sensei, you can say what you found, can you? I'm not going to say what you found when you're in the room.
Identified studies, not everyone contributes to the main outcome.
Yeah.
So that it depends on, so we compare the effect sizes of the meta-analyzed primary outcome against the proportion of trials out of the identified studies that contributed to that primary outcome. And the greater number of studies contributed to the primary outcome, the effect sizes became smaller.
Yes. So strongly suggesting selective publication of at the level of outcomes, and there's been other studies that show harms are greatly unreported. So if you get a significant, if you get a harm, it's 2/3 of trials won't report it. So that's really important. The selection bias about harms seems to be really severe. So that's selection bias. Selection bias is a really big problem. And then also I've realized that fraud is a very big problem too. And I told you that I've always been very interested in head injury. And so one of the treatments for head injury is this treatment called mannitol. Right? So basically, after you've had a head injury, your brain starts to expand inside your skull. And if the pressure gets too high, that kills the patient. So they give sugar solution into the veins, and it pulls water out of the brain by osmosis. And I thought, well, let's do a systematic review of this treatment to see if it really works. And I published a review in the Cochrane Library. I was the first author.